So we use the quotient rule when we want to take the derivative of two functions divided by each other, as f of x divided by g of x, and its derivative will be as shown. So here we have a function we want to differentiate using the quotient rule. If we call that function as h of x, then the top will be f of x and the bottom will be g of x. And we want again to differentiate, which finding the h prime of x. To do that, we will use the quotient rule, which is given by this equation here. First, we need to find these terms f, g, and their primes. So the first function will be the top, and the second function will be the bottom. Now we are finding their derivative. Here we use the lower rule. And then we can simplify this. Now we also need to find g squared. So we take the g and we square it. That will be x to the 3 plus 1 squared. Now we are ready to plug this value into the h prime. So f of prime will be 10x multiplied by g, which is x to the 3 plus 1. Always use parentheses here so you don't confuse yourself. And then all over g squared, which is x3 plus 1 squared. Now what we can do is multiply the 10x in front of the parentheses. It's gonna be 10x fourth plus 10x, and then minus 5x squared, and we multiply the two x's together, so we will add the power. Now we can see there we have a similar term, same power, so we can add these. And will be our resulting function. So this will be the derivative of that fraction. Here we have a different function and we want to use the quotient rule to find its derivative. So again, we started by writing what is the quotient rule, and then what is f of x, which we play the top, and g of x will be the bottom. And now we find their derivative. And g squared will be just 1 plus ex all to the power of 2. Now we are ready to plug these values into the equation rule. So f of prime will be 0 multiplied by the g function, which is 1 plus e to the x, and then minus 1 multiplied by g prime e to the x, and then all over 1 plus ex all to the power of 2. So the first term will go to 0, and we're left off with negative 2ex. And that's our derivative in here. That's the resulting of that fraction using the quotient rule. Here again we have a function and we want to use the quotient rule to find its derivative. We started by writing the quotient rule. So now what we want to find is what is f, g, and their derivative. f of x will be the top, g of x will be the bottom, and then we find their derivative. We use the exponential derivative for the first one, and then for second one we use the power rule. G squared will be just x squared to the power of 2, and then we can multiply the both of the power to be 4. And then again, now we are ready to substitute into the equation rule. Since we have all the values we need. So now what we can do is we can arrange these terms. Now we can factor x to the ex of the two terms, and then we can divide this x with the x to the 4th to be x to the 3 at the bottom, and that should be our answer for that fraction.